What was I saying? Integration by parts. Okay, it starts with the product rule. So I start with I'm doing the derivative here of, now with product rule, it used to be f and g. But in this unit, we started to use the variable u, and now I'm going to throw in the variable v. So it is f and g, but that's just translated right here to u and v. So they're getting the derivative of that. And we know the product rule, it's fg prime plus gf prime. So in regards to u and v, it's ub prime plus vu prime. Over here, I just gave you the reason. That's just the product rule. Okay, so then what we're going to do is I just rearrange the terms. So I just solved for uv prime. I solved for this one. So really, I guess I subtracted this one over, so it was negative vu prime. And then this one was together with that. And then I just reversed what side they were on. So it was just solving for uv prime, didn't do anything else there. Okay, got that one by itself. And now all you do for integration by parts is then you do an antiderivative, something like this stuff. You just do an integral of each part there. And so here's where the formula comes from. We're going to do the integral of uv prime. Now over here, so that's right here in the formula. Over here, though, the integral of the derivative, ddx, integral of the derivative of uv, that just cancels itself out, derivative and integral. And so that's why right here in the formula, we just have uv. The derivative and integral cancel itself out. Finally, over here, this just stays, minus the integral of vu prime. All right, so what this does, this is the formula. It breaks a more complicated integral down into this, which does have an integral in it, but it makes it an easier integral to compute. So we start with one we don't know, and we break it down, and we'll put these values in, and an integral of something we do know. I guess that's the goal, and usually it will break down to something we know. So again, like sum of u substitution, it only works in certain cases. You know, like I mentioned back here with u substitution, the very first one. Well, if this was 3, we let u be x cubed. Derivative is 3x squared. If this would have been 3x cubed or 3x to the 4th, it wouldn't have worked. So it doesn't, it can work for a lot of things, but sometimes just switching it barely there, it would not work. Okay, formula, yeah, breaks down an easier integral. So we will have a u, excuse me, and a v prime. This u is not at all like u substitution. So we use the same variable, but it's totally different. So don't think about u substitution at all when you're doing this. Totally different. Okay, and last thing before we try some, I'll sign up here. I said choices for u. There's this acronym that can help you decide the order of what to pick for u, because again, you got to pick u. I don't know, somebody just came up with this. Liate is the acronym. I'm glad you think it's funny. I don't know where to go from there, but that's just the acronym. I didn't make it up, okay? But as you can see, it's illustrated on yours. If there's a log in there, not exponential, but pure log, you would choose that for u first. If there's inverse trig, you would go there. Next would be algebra, so that'd be polynomial, like x squared, x cubed, x. Then you got trig, and then you got exponentials. So this would be like sine x or tangent x, and this would be like e to the x. Okay, you pick that. So go in that order. So even if there's like a trig and an algebra, a polynomial, you pick the algebra one for your u. Okay, really, we just gotta try some out here. So, any initial questions, though? Okay. So evaluate the following integrals. So what I'd like to do here is basically go through that. At this point, it's going to be a 3-step process if you're to get to parts. So first, here's the order you should try them in. do I know just a basic antiderivative rule? Well, I do for cosine, but not for x cosine x. Okay, so this one won't work. Then you try Then you should try u substitution. Well, if I let u be cosine x, the derivative would be negative sine x. There's no sine x up there. U substitution, you can't just let it be x. That'll never work. U substitution not going to work here. So the third choice is integration by parts. Okay, now for this you have to choose a u and a v prime in this formula. I need a u and a v prime, and if we get that, then we can integrate. All right, so the choice of u here, I said to go in this order. There are no logs. There's no inverse trig like cosine inverse. There is algebra, and it's x. Now for u substitution, I said you could never let u be x, but for this you can. Okay, so with this, I'm going to then write, here's what you do. You let u be x, or whatever you choose u to be, and you let v prime be everything else. So everything else up here, cosine x dx.
You don't do the derivative of cosine?
You mean like du? We will do that.
Oh.
Like the derivative of x. Yeah, we will do that. So guys, what we're gonna need, I could start the formula. We're gonna need u and v. I have u. I'm gonna need v. So what I'm gonna do in a minute is integrate both sides to get v. I'm also gonna need u prime. So I'm gonna have to do the derivative here. So basically what you need to do is you have u and v prime. You need u prime and v in order for the formula to have everything you need. All right, so what I'm going to do is I'm going to do u prime here. Now, for u substitution, I wrote du, which is the u prime. For parts, just to kind of separate these, I'm going to write u prime. So here different. So u prime, let's do that. The derivative of x is 1 dx. Then I'm going to need v. I have v prime, so if I do the integral of both sides, that will get rid of the derivative, and that will be v. So I do the integral of v prime, it's v, and on the right side, the antiderivative of cosine x is sine x. And by the way, we normally write plus c here. We'll just write it at the end though, with everything. Okay, now I just plug these in the formula. So again, I had u and v prime. I needed u prime and v in this formula up here. And now I just plug it in. Let me write it out down here so I don't scroll back up. Okay, so what I have here, I'm just going to write this. Okay, so this is my u in the formula, and this is my v prime, and so it'll equal, and I'll just plug in these now. So it's going to be equivalent to uv. So u is x, and v is sine x. Okay, so I just plugged in these two, u and v, minus the integral v was sine x. And then u prime is dx. All right, and so the last thing I got to do is just evaluate this one. And it is now an antiderivative we know. So here's the last step, x sine x. Let's see, minus the antiderivative of sine is negative cosine. So, is that right? It's really negative cosine. So that'll make this positive. And here's why I do throw in the plus c. Let's see. Okay, so again, with Ly8, we chose what u was, x. We let everything else be v prime. Then in the formula, you need u prime and v. So I just do u prime, a derivative. Here I need v, so I do the antiderivative. And then I just plug things in this formula. And it becomes this, and then it made an easier antiderivative I can compute. So let's just do a couple more. Now that I've shown you this one, any thoughts or anything I can answer on that one?
Can you scroll back up to like the saying at the top? Can you just give an example of each
What
of them?
saying?
Of like obviously like if it's
Right.
a log, we know what logs are.
Yeah.
Can you start at
Inverse
and
trig we haven't done much of. That'd be like if it's at sine inverse of x.
Okay, right.
And algebra is like that one, like x squared. I guess, I mean, if there was a number in front, you could pull the number out, but x squared, x cubed, any of these. I guess it could even be x to a negative power too. So. And then trig would be like sine x or cosine x or tangent x, cosecant x. And then final exponential would be basically e to the x. Could also, I'm trying to, if there was a to the x, like a number to the x, that would also work.
But if it's
So.
to a negative exponent, then it's inverse and it's not trig.
Well, if it's x to like x
Well,
to
yeah,
the
I
negative
mean-
2,
Yeah, I mean like sine or cosine.
yeah, that's inverse trig. That would be
Okay.
first or before algebra. Nice. Anything else? And we'll see a few of these like as we go along here, especially on the next page. All right, let's try another one. X, the integral of x e to the x. Again, let's just start with this. I don't know an antiderivative because they're multiplied. If it was just e to the x, I would. U substitution, can't let it be x for u substitution. If I let u be e to the x, the derivative is e to the x. There's not another e to the x out there. Parts will work on this though. So again, this is a different u than u substitution. We go in the order. There's no logs. There's no inverse trig. But again, there is an algebra on this. This one's at least a little bit similar to the last one. There is an algebra. If there was not an algebra, you might have gotten down to the end. E to the x would have been the last choice. But we found something first. Okay, you let everything else up there, not the integral symbol, everything else will be b prime. Then you just do one derivative and one antiderivative. So this starts off the same. U prime is 1 dx. And then here you do an antiderivative, and that works out nicely because the antiderivative of e to the x is just e to the x. I would write plus c, but I'm just going to write it at the end. Yeah. All right, so there's the formula, and again, really what we're doing is x is u, e dx, dx is v prime. And so I'm just going to plug it into the formula now, u and v. So u is x, v is e dx. See how this one kind of starts off the same as the last one, like x sine x. Just x and v is basically the same. X e dx minus the integral of v, which is e dx, and u prime is dx. Yeah. This was very similar to the last one. So it broke it down into an integral that we can now compute here. Just the integral of e dx. So I bring this down, x e dx minus integral of e dx is e dx plus c. I made a note to myself here too. If you choose the wrong u, so you're choosing like e dx here, it'll work all the way until you get here, and then it would have actually created a more complicated integral. So that would tell you, yeah, I chose poorly. So. I'm just gonna do 2 on the back to finish up with parts. Anything I can answer that one? Take that as a no.
No.
Hey, so here's a fun one. Here's a fun one on the back. ln of x. Again, this is one like tangent, substitution. We didn't know what it was yet. We found it here. So we know the antiderivative of 1 over x is ln of absolute value x plus c. We actually don't know the antiderivative of ln x itself. So we can actually do parts to get it. So I like to go through this process from here on out to decide, well, I don't know an antiderivative of this. That'll be step 1. Next, I would try u substitution. I can't let it be x. If I let u be ln x, the whole thing, well, it's not going to work there either. The derivative is 1 over x. There's no x up there. So finally, I try parts, and it does work. It's not guaranteed it will always work, but it does here. Okay, so what should I let u be?
Let it be.
What do I have log?
Natural.
That's a type of log. So yes. So I let it be. So I let u be. Again, so L was first, and that's a log. So I let u be ln x. I let everything else up here be v prime. The only thing that's left is dx. In other words, 1 dx. So there's really a 1 in front there. Okay, for the formula to work, I need to compute u prime and v. By the way, you can do u prime and v as you go along, but I just like to map it out first. You're definitely allowed to just do it as you go along. All right, so the derivative of ln x, 1 over x, dx. So then over here, I need to do an antiderivative. And again, this is really 1 dx. And there's really a 1. So the antiderivative of 1 is just x. Again, I would write plus c, but I'll do that at the end. Okay, now we just plug in the formula. I'll write down the formula here. Is uv minus integral of v prime. And again, right here, these are the values we know. U is ln x, and dx is v prime. So this is right here what we're computing. If you want to write it out like this, you could. This is u, and this is v prime. In any case, so I just got to plug in what u and v are. So u is ln x. I'm going to put in parentheses because then v is x. So I don't want it to look like x times x. Ln x times x. Okay, minus the integral of v, which is x, and then u prime is 1 over x dx. Look how that worked out. We need to compute this integral on the right here. And works out because these just cancel. It's just going to be 1 again, yeah. So let me bring this down. I'm going to put x first. Traditionally, I put that first. So x ln x. Minus, and then here, yeah, it's just the integral of 1 dx, which we just did. Right, it's just x. Plus c, and there we go. So that is the antiderivative of ln x.
The journey.
What'd you say?
The journey.
Oh, the journey. Yeah, what a journey. It's nice how it worked out here. If it wasn't 1 over x, it probably would have worked because Unless it would have created a polynomial we could have done. So again, that one, you know, what's interesting here on this one too is you choose u as like the only thing up there, and all that's left for b prime is cx. It still works out. Well, one more. Anything I can answer on that one? Okay. One more. X squared cosine x dx. I'll start with my order of the antiderivative. No, these are separate, yes, but don't know an antiderivative for that. U substitution. Again, there's not a composition. There's not an insight. And U substitution could also work in other cases, but I could let the x squared or cosine x is not going to work. Okay, but I'll try parts, and that will work. So again, lie 8, I don't have logs or inverse trig, but I do have algebra. So I'll let u be x squared. V prime is everything else, so cosine x dx. Okay, so I'll compute u prime and v. U prime, the derivative of x squared is 2x dx. And then the antiderivative here will give me v. Antiderivative of cosine is sine. Sine x. And I'll leave out the c for now. Alright, so I'm just going to write the right side of the formula here. So it's going to be uv minus integral v u prime. So I'll fill in u, x squared, v is sine x, minus the integral of v sine x. U prime is, let me put this in parentheses, u prime is 2x dx. I'm going to take another step. Let me just rewrite this so it's in a little better order. So I got x squared sine x minus, first let me pull out the 2. Right, I can pull that out, in or out of an integral sign. So let me pull that out. I got the integral, and traditionally you write the x first before the sine x. So I write it as x sine x dx. So I just pulled the 2 out and wrote this x in front of the sine x. Now, does anybody know the antiderivative of x sine x? I don't. So, because normally it gets us down like here, it was just 1. On the last page, it was like cosine x or something. It didn't work, right? But it made it easier. Because look, before it was x squared cosine x, now it's x sine x, so it's better. Any ideas on what we should do now?
Plus c.
Do it again.
Do it again, thank you. So right here, I'll just write parts again, or parts 2 times. Because right here, we can do an integration by parts. X sine x, does that look similar to this one? Let's go back. First one, x cosine x. So what I'm going to do, it does end up working, but, so this is all good. That, minus 2, all good. Right here, yeah, that'll come down. And then I'm just going to do the integral of this doing parts again.
Why are you just allowed to choose that the antiderivative doesn't apply to the 2 anymore? Like,
Coefficient, constant multiple rule, I think is what it's called.
so why couldn't you take the x with it? Do 2x?
You can't pull that out front of an integral. Just like derivatives and integrals alike, you can do the derivative of 2x squared with the 2n, or that's equivalent to 2 and then x squared.
Okay.
Derivative or integral, you can do. Either way, you can pull a coefficient out front. That can go across the integral symbol, but x's cannot. Or cosine x, and anything with x in it. let's see. So I will do integration by parts again. Let's see, look at this different color. So right here in blue, this box that I'm doing it again. So I'm thinking of y8, and there's no log, there's no inverse trig, but there's an x, and so it's algebra. So I'll let u be x, and work from there. B prime is everything else, sine x dx. I will compute u prime, which is 1 dx. And I'll do the antiderivative here. Both sides, antiderivative of v prime is v. Let's see, antiderivative of sine is going to be negative cosine x. So again, I'm going to bring these back in a minute, x squared sine x minus 2, but I'm just going to do this part first. I'm going to write the formula. So I'll just put in x for u. For v, it's negative cosine x. I guess I'll write it like this. Minus the integral of v, which is negative cosine x, and I'll just keep it like that for now. And then u prime is dx. So let's work this out. This is negative x cosine x. I think we go ahead and change this net minus a negative, because I could pull that negative out front. So minus a negative will become positive. And the integral of cosine is sine. So it's all positive plus sine x. And again, this is the end, so I'll go ahead and throw on the c now, plus c. Well, I need it at the end. I'll leave it. That's fine. I'll leave it on there. Okay, last thing to do is I need that really went here. So I need to bring all this down and just, you could have done it all at once. I just don't want to keep rewriting this. So let me write the final answer here. Okay, so I'm bringing down the x squared sine x minus 2. Okay, now that is 2 times this. I'm going to put this in parentheses. Negative x cosine x plus sine x. Just throw the c on the outside, because it's, you could say it's 2 times c, but c is any constant, so it doesn't matter. Last step I'm going to do is distribute the negative 2. So we get x squared sine x, and then a positive 2x cosine x, and then negative 2 sine x, and then plus c. Yeah. So we had an example of integration by parts twice. So we did it once. It got to here, which is good. It took this degree down 1. It was x squared cosine. That was x sine. It made it easier. Do it again. It's actually an integral we know. So again, it took a little work, but it got us there. I will say this to finish up. If you did college calculus or some more advanced part integration by parts, you actually, like this pattern, that it really is a pattern, and so you can integrate things if it was like x to the 6th or something. And you really look for a there's this pattern, I think it's called like tab something, where it you basically box out what the pattern is and use that instead of doing integration by parts 6 times. So. Anyways, how are we doing on that one? Any thoughts in general about integration by parts?